Hey guys. Alright, today we are talking about applying similarity. Make sure you write down everything that you see and make sure you write down everything that I write down. Alright, so our objective for today, I will be able to apply the concept of proportionality to find missing sides on similar figures. Well, first of all, what are similar figures? Well, if they're similar, they're going to have the same shape but not the same size. So you can see that with these triangles right here. They are the same shape and they are the same type of triangle, but they are not the same size, so they are just similar. And we are going to represent similarity with this symbol right here. Now, obviously, since these triangles are different sizes, their side lengths are not going to be exactly the same. These side lengths are going to be smaller than these, but they will be proportional. So similar figures do have proportional sides. Now, their corresponding angles are congruent. So that means that angle A on this triangle is congruent to angle D on the bigger triangle, and we can see that represented by the one line. So angles B and E are represented with two lines showing they are congruent, and angles C and F are represented with three lines to show they are congruent. Now, if we are missing a side on a figure, we are going to have to use a ratio to solve for it. Remember, a ratio is a comparison of two quantities. There are two different types of ratios that we will be using, within and between. Within just means we're writing a ratio using two sides on the same figure. So for example, if I come over here to this triangle, I'm going to take two numbers from this triangle and this triangle only. So let's say I select 10 and 6. So I would simply write 10 over 6. They come from within the same triangle. Now, if I was going to write a between ratio, that's writing a ratio between two corresponding sides on different figures. So I'm going between the triangles. So let's say I select 10 from the smaller triangle. That's on side AB. So I want to find the corresponding side, which would be the side that looks the same, from the bigger triangle. That would be side DE, and that number would be 20. So I'm taking this side from the smaller triangle, putting that over the side from the larger triangle, and I just created a ratio between the triangles. Alright, let's go ahead and do an example together of determining if two figures are similar. So example 1 says, determine whether trapezoid ABCD is similar to trapezoid HJKL. Now notice this trapezoid is not facing the same direction as this one, but that's okay. We just need to notice what our corresponding sides are. So what we want to do first is we're going to set up a ratio within figures. So that means I want to take numbers from the same trapezoid and then take numbers from the next same trapezoid. So let's start with the small one. I am going to use 10 and 6. So I'm going to create a ratio 10 over 6. Now, I've got to set up a proportion, so I'm comparing two ratios. So I took side LK from the smaller one. That was the diagonal side. So I want to come down here to the bigger trapezoid, and I'm going to take the diagonal side of this bigger one, which would be side DC, which measures 25 kilometers. So I will have 25. Then I took this 6 from this side of the smaller trapezoid. That was side LH. So I want to find the corresponding side on the bigger one, which would be side DA, and that one measures 15. So now that I have that set up, I have a ratio from the smaller, and then I have a ratio from the bigger trapezoid. I want to cross multiply. Now remember, two ratios are proportional if the cross products are equal. So I am going to take 10 times 15, and I want to see if that is equal to 6 times 25. So I've got to take these cross products and see if they're equal. Well, we know 10 times 15 is 150, and 6 times 25 is also 150. So yes, these figures are similar. But let's set up a ratio between figures. All right, so I'm going to use 10 again. So I'm going to take 10 from the smaller trapezoid. But now I want to put that over the corresponding side from the larger one. So if I take this diagonal side, now I'm going to take this one. So I'm going to put 10 over 25. And then I am going to take this 6 right here from the smaller, and I'm going to take this 15 from the bigger. Now remember, this side, LH, where the 6 comes from, that corresponds with the side DA that the 15 comes from. Always make sure that you are choosing from corresponding sides. So now I am going to do the same thing here. I'm going to set my cross products equal to each other, and I'm going to see if they match up. So we have 10 times 15. I'm going to set that equal to 25 times 6. Now, as we know from above, 10 times 15 is 150, and 25 times 6 is 150. So whether you set it up within or between, we're going to see that these figures are similar. Now we want to write the similarity statement. That simply means we're going to say this trapezoid is similar to this one. Now we have to be careful about how we write our letters. So on this trapezoid, it's called HJKL. So I am going to write those letters in order. HJKL. So I am going from this point to this point to this point to this point. So keep in mind the order that I have just gone in. I want to go in the same order on this trapezoid. So we have the large side, and at the bottom is H. So on this trapezoid, I want to look at the large side. On the bottom is A. So I know I have to start with A. Then I went from H to J across the bottom. So I'll go from A to B across the bottom. I went from J up to K. So I would go from B up to C. And then, of course, my last letter would be D. And remember, this is our symbol for similarity. So trapezoid HJKL is similar to ABCD. All right, now if we want to find a missing side, we're simply going to set up a ratio. We just have to decide if we're going to use within or between ratios. And on this example, I'm going to do both. After we do that, we want to set up a proportion. Now, we want to make sure x is in the proportion, because if we don't involve side x, then obviously we can't solve for it. Then we want to cross multiply and divide to solve for the missing variable. So let's look at these two triangles right here. Now, we want to know if they're similar, but we can figure that out after we solve for x. So let's start with the within ratio. So I am going to take this triangle here. I'm going to take the x, and I'm going to put it over the bottom, which is 10. So I'm going to take x over 10. So I want to set that equal to the corresponding side on the big triangle. So x was on AT. That corresponding side is OG. So I'm going to take that 30. Now I took x and put it over the bottom, so I'm going to take 30 and put it over the bottom on the bigger triangle, which is side DG. So that would be 30 over 60. Okay, now I want to cross multiply. Cross multiply and divide. So I'm going to have x times 60, which I can write as 60x. And I'm going to set that equal to 10 times 30. So 60x equals 300. I'm going to divide by 60 on both sides. Bring down my equal sign. 60 divided by 60 is 1, so I'm left with 1x. And 300 divided by 60 is 5. So that means this side measures 5. Okay, now let's set up some between ratios and see if we get the same number. So I am going to take x from this triangle and put it over the corresponding side that measures 30. Now I'm going to go back to the small. I'm going to take this 9 and put it over the corresponding side from the bigger, which is 54. Notice when I did the within, I took 10 and 60. This time I'm taking 9 and 54. So let's see if I still get x to equal 5. So now I am going to cross multiply. So I'm going to take x times 54 and 30 times 9 and set them equal to each other. X times 54 is 54x, and 30 times 9 is 270. Now I'm going to divide both sides by 54. I'm going to bring down my equal sign. 54 divided by 54 is 1, so I'm left with 1x. Now I am going to come out to the side here and work out 270 divided by 54. Remember, top dog in the house. Now, we know that x should equal 5, so let's put a 5 here and see if this works out. So, 54 times 5, well, 5 times 4 would be 20. 5 times 5 is 25, plus 2 is 27. So yes, we do get x equals 5. Now, to see if the triangles are similar, we can just set up a proportion using what we already have. So we could take this x, we could make that 5 over 10, and see if that's equal to 30 over 60. Now if we cross multiply, 5 times 60 is 300, and 10 times 30 is also 300. So yes, these triangles are similar. Now for the similarity statement, I am going to take the names of the triangles, and we are going to use the letters here. Now, I am going to start over here with letter C. So I am going to go C-A-T. So triangle, oops, that triangle does not look good. Let me do that again. That means triangle C-A-T is going to be similar. Now I've got to make sure that my letters match up. So I went bottom left, top to bottom right. So on this triangle I'm going to do the same thing. I'm going to go bottom left, top to bottom right, which is D-O-G. So triangle CAT is similar to triangle DOG. Alright, example 2, we are going to solve for x again using within and between. So first we want to set up a proportion for each one. Now I want you to notice that we have a small triangle inside of a larger one, but you can see that they are still similar. So I'm going to go within, and I'm going to start with this small triangle. I'm going to take x, which is the left side, and put it over the bottom of that small triangle, which is 4. So I'm going to take x over 4. Right, so I took the left over the bottom, so I want to do the same thing with the big triangle. So the left side equals 8, and I'm going to put that over the bottom, which it doesn't specifically say, but the bottom is going to be 2 plus 4 centimeters, which is 6 centimeters. So I'm going to put that over 6. Now I'm going to cross multiply. So 6 times x should equal 8 times 4. So I'm taking these cross products and setting them equal to each other. So 6x equals 32. Now I have to divide both sides by 6. I'm going to carry down my equal sign. 6 divided by 6 is 1, so I am left with 1x. Now I need to work out 32 divided by 6. So I'm going to come over here and do that. Remember, top dog goes in the house. 6 goes into 32 5 times, which is 30. I get a remainder of 2. I have a remainder and no numbers left to bring down, so I'm going to add a decimal and a 0. decimal goes up, 0 goes down. 6 goes into 23 times, which is 18. Get a remainder of 2, and add another 0. Now, if I keep going, obviously it's going to repeat, and I'm just going to have 5.3 repeating. So I am just going to stop here and just round it to the tenths. So I know I'm going to have another 3. 3 stays the same, so I would just have 5.3. So that's approximately 5.3. And remember, we're talking about centimeters here. All right, now between figures, I am going to take this x here from the smaller one. That's the left side of the smaller one, side OT. So I'm going to go to the left side of the bigger one, side JB, which is 8 centimeters. Now I'm going to take the bottom of the smaller one, which is 4. I'm going to put that over the bottom of the larger one, which is 6. Now I'm going to cross multiply. So I have 6 times x, and I'm going to set that equal to 8 times 4. 6x equals 32. So I've got to divide by 6 on both sides. And as we saw over here, 32 divided by 6 is 5.3 repeating, which we are going to round to 5.3. So I got the same thing for both of them. So our triangles are going to be similar. Now keep in mind, if we are going to multiply this out, if we do 5.3 times 6, like if we took 5.3 and plugged it in for x and we checked our cross products, remember 5.3 is repeating. So if we do 5.3 times 6, we are going to get 31.8, which is not 32, but that's because we can't do 5.3 repeating times that 6. Whenever we do it that way, we did round, so it's going to come out close, but it's not going to be the same because it's 5.3 repeating. So keep that in mind. But yes, these triangles are going to be similar. All right, now it's time for you to try. We have 2 triangles here. We want you to check and see if they are similar. And then obviously we do have this side missing, so you need to find 2 different ways to set up a proportion and solve for x. And then on the bottom we have 2 trapezoids, and we just want to see if you can tell us what the missing side is and determine if those are similar. Make sure you complete all of the you-try so that you can get full credit on your notes. Have a wonderful day, and we will see you next time in class.